Uh, Hello friends, so it's Avinash here once again, and the topic today is your illustrating behavior is of so this is about the illustrating behavior. Okay, that means your Hamilton equation or something like that. Yes, Hamilton rules actually. Sorry. So this is about just the simplest way I can explain you that the offsprings have copies of their parents. That means the parents they have the genes which they transport to their children's to be carried with generations. That means they're preserving their own genes to be get transmitted to succeeding. I mean, undergoes the down of their generation, the incoming generation. So to preserve their own their own genome to get spread over the generation, they have to protect their organism. I mean, to protect their children. Similarly, the family member also try to protect the children's, but it that selflessness and their non-selfness is something different. Getting my point? For example, I want to tell. For example, let's draw something. Hope you understand. For example, this is like your children. This is your parents. So each have single chromosome is applied to this. I mean, set of gene. So here you get the complete sets of this chromosome from both this female and male. That means from mother to father. So each possesses a relatedness to with this offspring is about 0.5. Sorry for the point. Okay, so it is about 0.5 is your relatedness of that offspring towards this mother or father. Similarly, this relatedness for this offspring towards its brother and sister is also 0.5 because they possess the similar types of gene from the common mother and father. Okay, so the relatedness of this offspring is 0.5 in all the cases. Okay, this is what exactly written, the coefficient of relatedness. The mother and father 0.5. Similarly, for brother and sister is 0.5. But during their generation wise, it will decrease. For example, the grandchildren and the grandparents will be 0.025 and 0.125. That means half of that of your common that previous generation. So this is your selflessness towards your own gene, that how you want to protect those genes. This is all about the relatedness. Okay, then come to the selection of the behavior that lowers individual's own fitness but enhances the reproduction success. So here is written that the selection of behavior that lowers, so this behavior that lowers the individual's own fitness. That means, for example, let me once again draw this one. So for example, here the children and here the parents. So to protect these children, they have to sacrifice themselves, and that is what we call the kin selection. And this is a behavior, and that behavior is your called the kin selection, which enhances the reproductive success. The transfer of this gene possessed, which is transferred by these parents to this offspring to carry out in down to. This is your thing that is called this is you call what? This is you call B. That means your B. The B is your benefit received by the recipient. Here, that the protection, that self what you call the sacrifice by those parents is you call the benefit of that recipient, and the sacrifice that being done or the is called the C. That means the incurred by the donor. That means the parents towards the offspring, the brother by towards his siblings. So this is what we call the C. That means your cost of incur by the donor to save this genome or gene, what you call the all the genes chromosomes. What? Okay, so this is your RB is greater than C, and only in this case, this means in this case it's only possible the kin selection, because the donor must have the lower value than this one. So we can also write this is as RV minus C should be greater than 0. Get it? So this is the kin selection and of Hamilton's rule. Here is some problem related that you can go through this by taking screenshot. Thank you very much. Hope you like.